Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for today's video, we will look at a question from Form 5 Chapter 2, Differentiation. So before we begin, you can take a look and try it by yourself first. By looking at part A, the things we can highlight is, for part 1 would be this 0. So later for part 1, we need to substitute x with 0. And for part 2, you see that there are two tables below. And we need to fill in the blanks and correct our answers to 4 decimal place. And for part 3, we need to find the limit for this function. Okay, so let's do it part by part first. So by subbing x with 0, you notice that the numerator and the denominator is 0. So here we can make a conclusion, which is f of 0 is undefined. Reason is because its denominator is 0. So for part number 2, we have two tables below and we have the x value. So we just sub these x value into this function. And remember to write it in 4 decimal place. Alright, so here are the answers. So in part 1 and part 2, what are we actually doing here? Now, teacher has put this equation into an application called Desmos, and to see the shape of this equation. So what you can see here is the curve, it looks very nice, right? And by looking at x equals to 0, we can see that actually it's quite nice. It's continuous the whole way. Because in part 1, we calculated it's undefined. So let's zoom into this point and to see what's happening. So now teacher is looking at the 10 to the power of negative 6 view, and we can see that when the graph approaches to x equals to 0, there is a very big change. Looks like a zigzag shape. So what this means is this graph cannot find an accurate value when it's x equals to 0. Because if this equation can help us to find an accurate value, it would be a straight line. But for this case, it's not. So for this case, we call it as discontinuous, whereby when x equals to 0, it is undefined. So now the question is, can we find the value by using another way? So our graph will look like this. So there's a curve, but when it comes to x equals to 0, there is a blank spot. Reason is because when x equals to 0, it is undefined. So another way to help us find the value where x equals to 0 is by using the limit method, which is what we done in part 2. So if you see the table above, you can see that our x values are getting closer and closer to 0. This is because we are looking from the left direction to the point. So we are trying to find what is the value of this point when we reach the red point. So here we found out it's negative 12. And for the table below, it's also the same thing. We view it from the right side. And we look at what is the value which is close to this red dot, but it's not in the red dot, which is also negative 12. So since these two numbers are the same, then we have found the answer, which is negative 12. And this answer is actually the answer for part 3. So since we cannot find the value where x equals to 0, but at least we can find the value where it approaches to 0. So this is the meaning of this expression. So when it comes to this function, what is the value where x approaches to 0? Not exactly, but approaching. So this would be negative 12. Alright, so moving on to part B, we have a equation here, and we need to express it into this form. And later, we need to find the range of values of x where this expression is more than 0. for differentiation, we have 3 levels. So for the levels and differentiation, I have explained in much detail in another video, so I'll put the link here. So the first level would be y, and if we differentiate y, we will get dy over dx, and we differentiate again, we will get d square y over dx square. So here we need to differentiate twice. Before we differentiate, let's multiply the x into here first, and we differentiate. So remember, when differentiating, we need to separate the equation using the plus and minus, and to differentiate part by part. So here, we will just multiply the number and the power minus 1. Here we can use the shortcut way, which is minus 4, removing the x. And to get d square y over dx square, we differentiate again. Number multiplied by power minus 1. And since this is a number, when we differentiate it will become 0, so we can just ignore. And now we can substitute the equations here to here. So our answer is 9x squared minus 4, and I have highlighted different colors for different expressions so you can see it clearly. So this is the first part of the question. Now the second part would be find the range of values of x where the expression that we have found just now more than 0. So range of value of x meaning our answers will have the inequalities, maybe more than or less than. So since this is a quadratic function, we can use a calculator to factorize it. And now since this is a quadratic inequality, we can use the graph method to help us find the answer. Since this is more than 0, so we need to find the range which is above the x-axis, which is here. So our answer would be x is less than negative 2 over 3 and x is more than 2 over 3. And we have completed this question. So the take-home point for this question would be we need to check whether the equation can be expanded. If yes, expand first, then only differentiate. So here means that for this part, we try to expand first instead of differentiating. So some of the students will use product rule to differentiate this first, which is to separate the x and x squared minus 4, differentiate first, and then need to cross multiply. But we don't have to do this because it will involve a lot of computation and also will increase the risk of more careless mistakes. So what I suggest is, since this equation is not difficult to expand, so we can just multiply the x into it first, then only differentiate. So you can save time and also save your marks. Okay, so if you are interested in this question's answer scheme, you can click the link in the video description, and you feel this is beneficial to you, please give a like, subscribe, and share it to your friends and classmates. And if you have any questions, feel free to comment below. Alright, so I'll see you very soon in the next video. Thank you.